Here we have AP calculus AB problem. There is a graph given over here. The graph of the function y equals to 4 positive cotangent x negative 2 times cosecant x shown above. Find the equation of the tangent line to the curve at point P and find the coordinates of point Q and equation of the horizontal tangent line to the curve at Q. Okay, there are two questions to be answered. One is we have to find the equation of the tangent line to the curve at point P. Okay, then the second question is we have to find the coordinates of the point Q and also we have to find the equation of the horizontal line to the curve at Q. Okay, let's answer the first question. That is, we have to find the equation of the tangent line to the curve at the point P. There is a formula to find the equation of a tangent line to a curve. Okay, let me mark it as 1 because we are answering the first question. So let me write the formula to find the equation of a tangent line. Let me finish writing. So the formula to get equation of a tangent line is y negative y1 equals to m times x negative x1. So here x1 comma y1 represents a point at where we draw the tangent line and m is the slope of the tangent line. So here we find the equation of tangent line at the point P. So then x1 comma y1, the point must be equal to the point we have at P, that is pi over 2 comma 2. Okay, to get the equation of the tangent line, still we need the slope of the tangent line. So what do we have to do to get the slope of the tangent line? For that, what we have to do is we have to find the derivative of the given function. That is, we have to find dy over dx of the given function. So the dy over dx represents the slope of the tangent line. So let me do it over here. That is y equals to 4 positive cotangent x negative 2 times cosecant x. This is a given function. Now let's find derivative on both sides with respect to x. If I find derivative of this y with respect to x, I'm getting dy over dx equals to this 4 will become 0. We don't have to write that. And the derivative of cotangent x is negative cosecant square x negative 2 times. So the derivative of cosecant x is negative cosecant x times cotangent x. Then we get dy over dx equals to negative cosecant square x. So when I multiply this negative 2 times negative cosecant x cotangent x, it will become positive because negative times negative positive. 2 times cosecant x times cotangent x. Okay, now I got the derivative. This is dy over dx. So this represents the slope of the tangent line, but we need the slope of the tangent line at point P. So to get the slope of the tangent line m at point P, what I have to do is I have to plug in this point pi over 2 comma 2 into the result of dy over dx. But in the result, when I consider the result of dy over dx on the right side over here, I don't find y. I just find only x over here. So what I have to do is I have to plug in the x coordinate of the point P for this x over here to get the slope of the tangent line at the point P. So we know that m represents the slope of the tangent line. So negative cosecant square. So for this x, we have to plug in the x coordinate of the point P, that is cosecant square pi over 2 positive 2 times cosecant pi over 2 cotangent pi over 2. Okay, now we need to find the value of cosecant square pi over 2. So for that, what we can do is we can like a cosecant square pi over 2 can be written as 1 over sine square pi over 2, because cosecant and sine, both of them, both the functions are reciprocal to each other. So to get the value of cosecant square pi over 2, we have to write as 1 over sine square pi over 2. So like to get the value of sine pi over 2, we can use either trigonometric ratio table or unit circle. So the value of sine pi over 2 is just 1. Since we have sine square pi over 2, that 1 has to be squared. So 1 over 1 square is just 1. So I got the value of cosecant pi over 2, cosecant square pi over 2, that's just 1. Now let's find the value of this cosecant pi over 2. The same concept, that is cosecant pi over 2 equals to 1 over sine pi over 2, which is equal to 1 over 1, that is 1. Now to get the value of cotangent pi over 2, it can be written as 1 over tangent pi over 2. So because tangent and cotangent, both of them are reciprocal to each other. So cosecant pi over 2 can be written as 1 over tangent pi over 2. So we know that the tangent pi over 2 is undefined, or it can be written as infinity. Whenever I divide a non-zero number by infinity, it is equal to 0. So now I got the values of cosecant square pi over 2, which is 1. Cosecant pi over 2 is just 1. Cotangent pi over 2 is just 0. Now let's plug in the values over here. So for this cosecant square pi over 2, we can plug in 1. Positive 2 times the cosecant pi over 2 is just 1. Cotangent pi over 2 is 0. So m is equal to negative 1 positive 2 times 1 is 2. 2 times 0 is 0. So finally, I'm getting the slope of the tangent line negative 1 at the point P. So now what we need to do is just have to plug in the stuff over here in this one. Like let me write here y negative y1. The value of y1 is just 2. That is a y coordinate at the point P. And m is the slope of the tangent line at the point P. So we got it, that is negative 1. We can plug in negative 1 for that one. x negative, x1 is the exponent of the point P, that is pi over 2. Okay, this is the equation of the tangent line to the curve at point P. So now we have answered the first question. Okay, now let's answer the second question. Okay, let me erase the stuff over here. According to the second question, we have to find the coordinates of point Q and equation of the horizontal tangent line to the curve at Q. Okay, so here to get the coordinates of point Q, let's consider this statement over here. That is the equation of the horizontal tangent line. So that is the tangent line drawn at point Q is horizontal. So whenever a line is horizontal, its slope is equal to 0. So since the tangent line at the point Q is horizontal, the slope of the tangent line we draw at the point Q to the curve must be equal to 0. Okay, now let me mark it as 2. So because we are answering second question, already we got the slope of the tangent line, that is dy over dx of the given function, that is equal to dy over dx equals to, that is this 4 will become 0, then we get negative cosecant square x positive 2 times cosecant x times cotangent x. Already we got this one when we answered the first question. We got the slope of the tangent line. Since the tangent line at the point Q is horizontal, the slope has to be 0. That means this dy over dx must be equal to 0. So since dy over dx equals to 0, the stuff which is equivalent to dy over dx also must be equivalent to 0. That is negative cosecant square x positive 2 times cosecant x times cotangent x must be equal to 0. So we find cosecant x as the greatest common divisor for these two terms. So we can factor that cosecant x out. I mean, we can factor negative cosecant x out. If I factor negative cosecant x out, then I'm getting just cosecant x. I'm left with just cosecant x in the first term. And since I factor negative sign, this positive will become negative. And since cosecant x is factored, we are left with just 2 times cotangent x. So 2 times, sorry, it's not 2 cosine x. It's 2 cotangent x equals to 0. And also we can verify the fact that what we have done is correct or wrong. When I distribute negative cosecant x to cosecant x, it will become negative cosecant square x. When I distribute this negative cosecant x to negative 2 cotangent x, I am getting a positive 2 times cosecant x times cotangent x equals to 0. Okay, here the product of two quantities equals to 0. So either the first quantity, that is negative cosecant x equals to 0, or the second quantity cosecant x negative 2 times cotangent x equals to 0. Okay, so let me continue the stuff over here. Okay, now the first equation, negative cosecant x equals to 0, over here I multiply both sides by negative 1. When I do so, I'm just getting cosecant x on the left side, because when I multiply this one by negative 1, so negative 1 times negative cosecant x will become just cosecant x. When I multiply the right side 0 by negative 1, it's still 0. Okay, cosecant x equals to 0. And so here in the second equation, we can write this cosecant x as 1 over sin x, because the sine and cosecant, the two trigonometric functions are reciprocal to each other. And negative, using the reciprocal trigonometric identity, I wrote this cosecant x as 1 over sin x 2 times. And using the coefficient trigonometric identity, I can write this cotangent x as cosine x over sin x equals to 0. Okay, this cosecant x can be written as 1 over sin x equals to 0. Now in this equation, if I multiply both sides by sin x, I'm just getting 1 on the left side, and 0 times sin x is just 0, sorry. Okay, so when I multiply both sides of this equation by sin x, I'm getting 1 equals to 0. So actually it is a false statement, because 1 and 0 cannot be equal. So when I'm trying to solve the first equation, cosecant x equals to 0, I'm getting a false statement over here, and also the x is no more. So we don't get any solution. I mean, we don't get any value for x from the first equation, cosecant x equals to 0. Okay, now let's solve the second equation, that is 1 over sin x negative 2 times cosine x over sin x equals to 0. So here we have subtraction of two fractions with the same denominator sin x. So we can take the sin x as a common denominator. Then we get 1 negative 2 cosine x over sin x equals to 0. When I multiply both sides by sin x, I'm getting 1 negative 2 cosine x equals to 0. If I subtract 1 from both sides, I'm getting 2 cosine x equals to negative 1. Then I divide both sides by negative 2 to solve for cosine x. As negative will cancel out. So then I'm getting cosine x equals to, when this negative will cancel, I'm just getting 1 over 2. Okay, now when I'm trying to solve the second equation over here, I'm just getting cosine x equals to 1 over 2. Okay, so when I look at the point, particularly the x coordinate of the point Q, it lies between 0 and pi over 2. And we cannot consider the x coordinate of Q as 1, because the question clearly says we'll have to do algebra to determine the coordinates of point Q. Its value is not 1. So the x coordinate at the point Q is not 1. So anyways, the exponent of the point Q is between 0 to pi over 2. So this interval 0 to pi over 2 covers only the first quadrant. So since the exponent of the point Q lies between 0 and pi over 2, so here we have to solve for the angle measure x in this equation in the first quadrant from 0 to pi over 2. So that can be done easily using unit circle or trigonometric ratio table. So like the value of cosine x equals to 1 over 2 when the angle measure x is pi over 3. That is when angle measure x takes 60 degree, the value of cosine x is 1 over 2 in the first quadrant. Okay, now I got the x coordinate of the point Q. Okay, so still I have to get the y coordinate of the point Q. How do I have to get the y coordinate of the point Q? So for that, let's write the given function, that is y equals to 4 positive cotangent x negative 2 times cosecant x. Now in this original function I have to plug in x equals to pi over 3 to get the y coordinate of the point Q. So let's plug in x equals to pi over 3. Then I'm getting y is equal to 4 positive cotangent, let me write it, cotangent pi over 3 negative 2 times cosecant pi over 3. So y equals to 4 positive. So to get the value of cotangent pi over 3, what we can do is we can write this one as 1 over tangent pi over 3. The value of tangent pi over 3, tangent 60 degree is, it can be written as 1 over tangent pi over 3. So we have to write the tangent pi over 3 in denominator. The value of tangent pi over 3 is just square root of 3 negative 2 times. So cosecant is a reciprocal function of sine. So to get the value of this one, I have to write 2 times 1 over sine pi over 3. The value of sine pi over 3 is square root of 3 over 2. Then I'm getting y equals to 4 positive 1 over square root of 3 negative. When I simplify this one, that is, it will become 4 over square root of 3, because this can be written as 2 times 1 times 2 over square root of 3. That is, I change this division as multiplication. I take reciprocal for the square root of 3 over 2. That will become 2 over square root of 3. So when I multiply this one, 2 times 1 is 2. 2 times 2 is 4 over square root of 3. Okay, now let's do further simplification over here. So 4 positive, so not positive. So here we can combine these two fractions because both the fractions are the same denominator, square root of 3. So I can take the common denominator, square root of 3. When I combine the numerators, positive 1 and negative 4, I'm getting negative 3. Okay, let me continue over here. Y equals to 4 negative. The 3 over here can be written as square root of 3 times square root of 3 over square root of 3. The square root of 3, square root of 3 will cancel out. Finally, I'm getting y equals to 4 negative square root of 3. Now I got the coordinates of point Q, that is x coordinate of the point Q is pi over 3 and y coordinate of the point Q is 4 negative square root of 3. Okay, now I need to find the equation of the horizontal tangent line to the curve at Q. Okay, let me erase the stuff over here. Okay, let me mark the coordinates of Q over here, that is pi over 3 comma 4 negative square root of 3. Okay, now let's find the equation of the horizontal tangent line to the curve at the point Q. Let me write the stuff over here. Equation of horizontal. To get the equation of an horizontal tangent line to the curve at Q, we have to use the same formula. That is y negative y1 equals to m times x negative x1. So here x1 comma y1 represents the point at where we draw the horizontal tangent line to the curve. So we draw the horizontal tangent line to the curve at the point Q. So then x1 comma y1 represents a point Q. Then it has to be equal to pi over 3 comma 4 negative square root of 3. And m is the slope of the horizontal tangent line. So already we have discussed, so if a line is horizontal, always its slope is equal to 0. So since tangent line we draw to the curve at point Q is horizontal, so its slope must be 0, that is m has to be 0. Okay, now what we have to do is just have to substitute these values in this equation over here. Okay, let me do it. So y negative, for y1 we can plug in the y coordinate, that is 4 negative square root of 3. And the value of m, the slope of the horizontal tangent line is 0 times x negative x1 is pi over 3. Okay, so y, we can distribute this negative sign to this, and then I'm getting negative 4 positive square root of 3. So 0 times x negative pi over 3 is still 0. Okay, now I got the equation of the horizontal tangent line to the curve at Q. So we can leave this equation as it is. Otherwise, we can solve for y. For that, we have to add 4 to both sides, and also we have to subtract square root of 3 from both sides. So when I do so, this negative 4 positive 4 will cancel. Positive square root of 3, negative square root of 3 will cancel. I'm getting y equals to 4 negative square root of 3. This is the equation of the horizontal tangent line to the curve at the point Q.